p160, we're given a force that's acting on a 2 kilogram object that moves in 4 seconds from its initial position to a final position. Find A, the work done on the object by the force during that time interval, the average power due to the force in that time interval, and the angle between vectors di and df. So first of all, for A, remember we've got the force here. It's in unit vector notation already. We've got the displacement, which is going to be the final minus the initial, and if you subtract those two unit vectors, you get this. So the work done is just the dot product between those two. Again, a quick reminder with dot products, we take the common coefficients. So for example, 3 times negative 8 is going to give us a negative 24. 7 times 6 is going to give us 42. And then 7 times 2 will give us a 14. The total work done then is going to be 32 joules, which is kind of nice. B, the average power. Well, remember, power is energy over time. In this case, the 32 joules divided by the 4 seconds it takes. They gave us the time interval it would take. So the power is just simply going to be 8 watts. And then finally C, find the angle between those two vectors. This is where it comes in quite nice. Remember that the dot product is equal to the magnitude of the first vector times the magnitude of the second vector times the cosine of the angle between it. In this case, the dot product is simply going to be this, and you might say, well, where is that coming from? I'm taking the first term of d1, which is 3, times the second term here, negative 5 gives us negative 15. The negative 2 times 4 gives us negative 8, and then finally 7 times 5 gives us the 35. The magnitude of the first one, we're just taking each of its components squared, taking the square root of it. This one here the same way. And so we end up with this, just doing a little bit of math. And then solving this one, you can very quickly come up with the angle between them is about 78.2 degrees. This one was a good practice with a little bit of definition of work, definition of power, and going back to unit vector notations. Good luck!